Here, we are going to mention 3 things about root. In the previous video's derivations, we took this step. So we assume that if 2 exponentiations with the same power are equal, their bases are also equal. Well, that's true if the power is odd. But if it's even, yes, they can also be equal, but they can also be negatives of each other. Yes, remember that a number to an even power are the same with that of its negative, like those. But of course, in the derivation, we are dealing with roots, which, if the index is even, are never negative. So, it's never the second case. So, they are equal and we have no problem there. Well, normally. The second thing is about notation. We know that if a root doesn't produce a whole number, we can just write it as root, but try to make the radicand minimum. That means we examine if the radicand has some factors that we can bring outside of radical. For example, if we see square root of 8, we know that 8 is 4 times 2, and 4 has a square root of a whole number. Thus, we separate them and take the root. So the radicand is now 2 and its minimum. The third thing is also about notation. For some reason, people don't like roots in denominator. So if you meet one like this, it's better to move it up. Okay, but how? Well, if down there is square root, we multiply the expression with that root over that same root. Okay, since this is basically 1, we didn't alter anything. But now we can convert the multiplication below into exponentiation and see that the power and the index are the same. Hence, the exponentiation and root cancel. So, we've moved the root. But what if it's cube root down there? Similar trick. But to get rid of a cube root, we need power of 3. So, we need 3 roots in the denominator. Thus, we multiply the expression by this twice. Then, we change the multiplications of roots below and also above into exponentiations and simplify the denominator. Okay, next time we'll solve some problems regarding this business of taking root. But for now, thank you very much for watching.